Hello everybody. In this video we are going to see how we can do one sample hypothesis testing when we only have summary statistics, and this time we are going to be doing this inside of Excel. Okay, so here's what we do. Let's start off by reading this scenario. So it says a shareholders group is lodging a protest against your company. The shareholders group claimed that the mean tenure for a chief executive office was at least 10 years. A survey of 76 companies reported in the Wall Street Journal found a sample mean tenure of 8.8 years for CEO with a standard deviation of 5.4 years. You don't know the population standard deviation, but we can assume that this population is normally distributed. You want to formulate and test a hypothesis that can be used to challenge the validity of the claim made by the group at a significance level of 2%. Your hypotheses are the following. So it has that the null hypothesis is that the true mean is greater than or equal to 10, and the alternative hypothesis is less than 10. So how did we get those null and alternative hypotheses? Well, if we go and look up in this problem, the null and alternative hypotheses will always be established in the scenarios. So from here we see that the shareholders group claimed that the mean tenure for a chief executive office was at least 10 years. This is the baseline claim that they are running off of, which becomes our null hypothesis. The alternative hypothesis is in contradiction to this. So it says you want to formulate a test that can be used to challenge the validity of this claim. That translates out to a test in opposition to this baseline assumption. So the first thing that it asks us is that it says, what is the test statistic? It's asking us for a t-score. So we need to gather some data real quick. The first things we need to know is what mu sub 0 is, the hypothesized true mean. We need to know x bar. We need to know the sample standard deviation. We need to know the sample size. We'll do n. We need to know the standard error. We need to know alpha. And that should get us started for things that we need right now. So the hypothesized mean that was given to us, so this baseline claim, was 10. It's what you put in your null hypothesis. The sample mean that they found was 8.8 years. So we'll put 8.8 here. And for S, our standard deviation, we'll do 5.4. Our sample size was 76. And our standard error, while it doesn't give it to us, we can calculate it. It's equal to our sample standard deviation that we just got here, and we're going to divide by the square root SQRT of n, and we can hit enter. And that gives us our standard error. Our alpha level is provided to us. It says that it wants us to test at the 2% level of significance. Okay, at this point, it's asking us for our test statistic, or our t-score. And again, remember that the t-score is just x bar minus mu sub 0, our hypothesized mean. Oops, that should be a minus sign. Sorry about that. Minus. And we're going to divide by the standard error. So t-score, oops, if we do that, let's delete that out. Oh my goodness. Here we go. Let's delete that and delete everything else. Okay. Our t-score is going to be equal to, we will do parentheses, x bar minus mu divided by the standard error. I am doing poorly on typing. Here we go. Divided by the standard error, and we get negative 1.9. Okay, fabulous. And if we check our answer here, we see that, yes, we did in fact get the right answer. The next thing that it asks us for is the p-value. Let me do a little drawing real quick to help us see what we're talking about. So let me just draw, and let me pin this down so that I can actually use some of these things. And let's start off with, let's just do black. Okay, so we have this normal distribution, and whenever we do hypothesis testing, we are going to assume that the baseline claim is true until the data claims otherwise. So we see that the null hypothesis is saying that the true mean is equal to 10. And we also know that we can scale this thing by our standard errors, right? So we know that the standard error is equal to about 0.6. I'm just going to say, for the sake of drawing simply up here, is going to be 0.6. Well, that means that down here, this is going to be 9.4. And then down here, this is going to be 8.8. Great. So we see that our sample mean actually was like exactly right here. X bar is equal to 8.8. Okay, so how many standard errors away from the mean are? Well, from my little drawing here, it looks like a roughly 2, and what we calculated is about 2. It's negative 1.9. Cool. What's the p-value then? Well, the p-value is saying, well, let's assume that the null hypothesis is in fact 10. It's saying what is the area, oh, I don't like that. Let's do a better color than that. Let's do a gold. It's saying what is the area beyond the null hypothesis? Because the p-value says, what's the probability that we would see x bar or more extreme given that our null hypothesis is true? And we know that it's pretty small, but I don't quite know if it is like really, really small, because I have to hit 2% of the rarity of an occurrence. Remember, alpha equals, let's kind of type this out real quick. Alpha is the rate we are willing to make a type 1 error which is a false positive. Basically, a false positive is saying that, hey, I think that the CEO is wrong, and so I'm claiming that I found something important, like this false positive, but in reality, the original claim of 10 years really is the true statement. Alpha is this rate that we're willing to make it at, and we have to have a p-value. This probability that we would see this x bar has to be less than the rate that we're willing to make a type 1 error. So in this case, it's got to be less than 2%. Okay, so how do we figure out our p-value? So let's do a definition again. P-value is the probability of seeing a sample mean as or more extreme than x bar given the null hypothesis is true. Oh my goodness, true. All right, so let's figure out how do we calculate out this little orange region. Okay, in Excel, we can calculate out the p-value with a handy little piece of code. We can do t.dist, and there are 3 options here that we can do. If we are doing a left tail test, which corresponds to a left, we use just tdist. Let me write this somewhere. Let me put up a note here. Note, t.dist for a null hypothesis that uses, or sorry, not null hypothesis, an alternative hypothesis, excuse me, that uses a less than sign. You use t.dist.rt for right tail for a null hypothesis, oh my gosh, alternative hypothesis that uses a greater than symbol. And use t.dist.2t for a alternative hypothesis that uses a not equal sign. In programming and typing, it's easier to type an exclamation point and an equal sign, but that means not equals. Okay, so for our scenario, what we're doing here is we are doing a 2-tailed test, or not a 2-tailed, we're doing a 1-tail less than test. So we are going to use here equals t.dist, and then we got to know what we need to put in. The first thing it says is just x. Well, what it's asking for really is your t-score. You got to click on the t-score here. Then comma. It wants degrees of freedom, and shoot, we did not calculate degrees of freedom. We'll put it in right here. I'm just going to click here for the second. And then we need to put another comma. We need one more argument, and it asks, do you want cumulative or do you want the probability? For all of our stuff, we're just going to be typing in the word true, and we'll hit enter. And it's really angry at me because I don't have the degrees of freedom. Let's go back here. We'll say the degrees of freedom is equal to just the sample size minus 1. And we'll hit enter. And now when we come down, we get a p-value of 0.028. And if we look at our answer, we got it correct. Now notice that our p-value is greater than alpha. We didn't quite cross the threshold of where alpha is. So if we looked at like our alpha line here, let's kind of put this in blue. The line that alpha said that we needed to hit was right here, and it's just a little bit smaller. So we have data that almost shows significance, but not quite. So here we are going to fail to reject the null hypothesis because we didn't quite cross into that threshold. We didn't quite hit that 2% level. And so it says, as such, the final conclusion is that there is not sufficient sample evidence to support the claim that the population mean is less than 10. We got close to getting there, but not quite. Now, one thing that sometimes we also need to do is we need to calculate out this t-critical, t-crit. And there is a way to calculate out our t-criticals as well. Let me insert just a little bit of rows so that we got a little bit more information. We can use t dot inverse. And notice how we have a t dot inverse and a t dot inverse two-tail. It's handy here. What we're going to do here is for our one-tail test, so we'll say, let's copy these because they are close to what we're going to use up here. So note for the t dot distribution for a less than or a greater than, we can get rid of this because it uses the same thing for the left tail and the right tail. And we're not using dist, we're going to use INV. And same thing down here, INV. Okay, so how do we go through and we do this? So we're just going to go ahead and click in here. We're going to do equals t dot inverse. And we need to put in a probability. The probability we're going to put in is the alpha to calculate out our t-critical. That would be how many standard errors away from the mean can we go before we're going to reject the null hypothesis. So we put in our alpha and we put in our degrees of freedom, and we're going to close it. And then I'm also going to include in this the absolute value. So when we use the absolute value here, it forces you to determine if we are going less than, so that would be a negative t-critical, or if we're going positive as a positive t-critical. It'll get the magnitude correct, but you've got to get the direction by understanding, is our x bar less than, and are we doing a less than test, or are we doing a greater than test? Okay, so here's my t-critical if I'm doing a one-tail test. And if I'm doing a two-tailed test, the only thing that you got to change is to dot to t. And it'll calculate out your t-criticals if you're doing a two-tailed test. All right, let's go ahead and delete those though. Let's just do our one-tailed test, and there's our t-critical. So just like we were able to compare our p-value to alpha, and we knew that our p-value was greater than the alpha, and we failed to reject the null hypothesis, we can also compare our t-score to the t-critical. So notice I did the absolute value here. If you want to do this correctly, maybe I'll add in one more step here. I won't combine these. Let's copy this, and I'll give you one more thing. So you're going to do the absolute value of the t inverse for when you are doing greater than, so that gives you a positive value. And here we go. Okay, let's do it like this. This is a little bit more clear. Let's get rid of that absolute value since we are doing a less than test. Whoops, equal sign. And run this. So we know that our t-critical our t-score did not get more extreme than our t-critical. We did not get far enough away from the hypothesized mean. So sometimes we use our t-criticals to do the comparison. And I'll do another video on just looking at how to calculate out t-criticals and p-values, but I wanted to show you like in context of this whole thing. Okay, so there it is from top to bottom, how to do each of those. And I hope that that helps you if you decide to use Excel, that this can walk you through of how to calculate out your t-scores, your t-criticals, and your p-values. The last thing is that you also might want to do a, you also may want to do a confidence interval. Oops, let's go down here. A confidence interval. Oops, I'm sorry. Here we go. Oops, nope. Well, maybe if I minimize, it'll come back up how it's supposed to. There we go. Okay, if we're doing a confidence interval and we want the lower end, we actually have everything that we need in order to do our confidence intervals, the lowers and the uppers. So remember, it's just going to be equal to x bar, for the lower, it's going to be minus our t-crit, and it's going to be minus here, always like the absolute value of the t-crit. and we times by the standard error. Okay, so let's go ahead and actually do it. So here we're going to do x bar minus, let's do the absolute value of our t critical times the standard error. I don't want to copy this whole thing. Control C, we'll enter. And let's paste it here. And we are going to do plus. So it's basically plus or minus the margin of error. And we hit enter, and there we go. So we've got our lower bound and our upper bound of where we think that the true mean actually is. Excel is very handy, and the tools are useful for when you do not have when you don't have the raw data. Now the only difference here is that if you had the raw data, we would just be using our functions like average and like stdev.s in order to calculate out like the sample standard deviation. Anyhow, I hope that helps you out, kind of directs you in the right direction of how to do these calculations using Excel. Best of luck to y'all.